Good day. Today I will now discuss about electrical circuit analysis. So I will now show you the slideshow. Electrical circuit analysis for advanced math for ECE. So what is electrical circuit analysis? In this topic, we will learn how to analyze circuits of RLC, resistor, inductor, and capacitor circuits by the use of Laplace transform and certain calculus. We will be able to obtain the easier way in finding their values. We will make use of the Ohm's law, Laplace transform, and other topics that will help us analyze the RLC circuit. For the resistor, VR is equals to IR times R. In Laplace, we will get it as VR is equals to R times the current. Therefore, we have IR. For the inductor, for the Vt time 2 Vs, the frequency domain, so we will have Vt times L di over dt is equals to Ls times I of S. For the capacitor, V of t is equals to 1 over C times the integral of it dt. We will have V of S equals to 1 over SC I of S. For the impedance of each component, for inductor we have SL, for the capacitor we have 1 over SC, and for the resistor is the resistor itself. Circuit conversion for inductor, we all know that di over dt is equivalent to Is times the initial state I of 0. We will now multiply both sides by L. So L di over dt is equivalent to Lsi of S minus Li initial. In here you will see the circuit. This for the Ls. This is the LILO and the current moving to the right. For the capacitor, we know that the integral with the limits of 0 to infinity, I of t dt is equivalent to I of S over S plus integral of infinity to 0, I times t, I of t dt all over S multiplied by 1 over C. Now we will get Vc of t is equivalent to 1 over C integral of I of t dt, which is also equivalent to Vc of S is equals to Is over Sc plus 1 over Sc integral of it dt. Now we will get the final equation. Vc of S is equals to I of S all over Sc plus Vs over S times 0. This is the initial state. This is the equivalent circuit for the capacitor. This is 1 over Sc. The AC will become Vt of 0 and the current moving to the right. Here given an example with 9 volts AC, a switch could be open or closed, a 2 ohm resistor 557, 0.2 Henry for our inductor, and for our capacitor 50 microfarad. Now our condition is at t is equals to 0, the initial state, the switch is closed, then therefore the inductor, this will serve as a wire, and the capacitor will serve as an open circuit. And to the next slide, we will show that the capacitor is gone, and this should be a wire because it serves as an a short circuit. In here, using Ohm's law, we will find ILO is equals to 9 volts all over 2 plus 5 ohms. Then therefore, we will have a current of 9 over 7. Using the voltage divider, Vc of 0 is equals to 9 times 5 over 2 plus 5 is equals to 45 over 7 volts. After t is equal to 0, the switch is moved. We will only consider this circuit with 3 resistors, the capacitor, and the inductor. This is now the equivalent circuit, which we will only directly substitute the values. For LILO is equals to 9 over 7 times the inductor, 0.2 Henry, which will give us 9 over 35 volts. For the VCO, 45 over 7S, we will only add S from the denominator to the denominator. So next for LS, 0.2S. 1 over SC for our capacitor is equals to 1 over 50 times 10 raised to negative 6S. So that's it. And another example for a simple RC circuit, T is equal to 0, VC is equal to 0. At T is greater than 0, we will use the voltage divider. Vs is equals to 1 over 3S plus all over 2 plus 1 over 3S. Now we will use the partial fraction A over S plus B all over 6S plus 1, and it will we will get out the 6S, so therefore we will multiply it to 1 over 6. So A of S plus 1 over 6 times B all over S plus 1 over 6. Using the cover-up method, we have B is equals to 1 over S is equals to negative 6, and for A we have 1 over 6S plus 1, which will give you 1. Substituting it to A and B, so we have 1 over S plus 1 over 6 times S plus 1 over 6. Now we will use the inverse Laplace, which is equivalent to ut plus 1 over 6 e raised to negative 1 over 6t ut. Making it more simplified, we will have 1 plus 1 over 6 e minus raised to 1 over 6t ut. So that's it. That's the inverse Laplace of the current circuit. So I hope you enjoyed watching and have a good day.